Okay, exploration 6.4, transformations of exponential and logarithmic functions. So the directions say each graph shows the transformations of the parent functions f of x equals e to the x. Now remember, that's just our natural based exponential, 2.718. And then we have f of x equals natural log x, and that is the inverse of that e to the x. So what our job is today is to try to match these 6 functions with these 6 graphs. Now, if possible, I would really like you to focus on doing this without the use of Desmos. However, by all means, after you've been working for a while, if you're still stuck, you're welcome to check your answers in Desmos. So the first thing I want you to think about is what we know about transformations of functions. And I want you to try to take a look at what you're seeing in these functions and see if you could find a way to match that relationship that you're seeing in these graphs. So I'm going to actually model one example for you so you understand what I'm looking for. So when I take a look at these functions, I'm going to focus in right now on function A, which says g of x equals e to the x plus 2 minus 3. Now when I look closely at that function, I definitely see that it's an exponential function. Now because of this e here, I'm going to say that this here means we have exponential growth. So what I'm looking for is a graph that looks like this. So this is exponential growth. So I'm looking for a curve that kind of goes left to right, goes up. So really I'm looking at A and F as options. Now, when I look closer at A and F, I see that they both have asymptotes, right? Which is normal for an exponential function. But I'm noticing that A has an asymptote at -1, and F has an asymptote here at -3, right? And that's that line it never crosses. Now, when I look closely at the function, I see here this -3. And so I'm going to assume that this -3 here is also our asymptote. And in this case, it actually is. Now, when you actually look at the graph, this -3 is actually shifting our entire exponential down 3. So that's literally what I'm going to write. It's a shift of down 3. Now, what's interesting, if I look at the graph that it matches, the one that shifts down 3, I will also notice that my entire graph seems to have moved not just down, but left as well. So if you look closely, you'll notice that the traditional exponential function crosses at 1, and so a shift of down 3 would move this here. However, this point here is over here to the left 2. So I'm going to take a look up here and see if that makes sense based on this function. Now if I look closely here, I'm sorry it's a little blurry, this +2 then tells me that my graph goes left 2. So I have a shift of down 3, a shift of left 2, and if you remember from before, when we did transformations, that if it's inside the function, plus is always the opposite of what it looks like, it's left. So I know that this is exponential growth, it goes left 2, and it shifts down 3, and then of course we say it matches graph F. So we're going to put here graph F. And then all of this here would be a complete answer for A. Okay, I need you to do the exact same process for B through F, and then after you've completed that, you're going to turn it over, and you're going to be identifying the domain, range, and asymptote for each function. So if you take a look at what we found on graph F down here, we're going to notice that we can identify the domain, range, and asymptote. So let's put here A, which was f of x equals e to the x plus 2 minus 3. And then we're going to put the domain, we'll just make 3 columns, the range, and the asymptote. Okay, so the domain for this function, if we go ahead and take a look at that graph, is all the possible x values. Now, if we look here, we can see that we can actually plug in pretty much any x value. I can plug in negative 100, I can plug in negative 4, negative 2, negative 1, 0, 1, 2, and I can continue to plug them in, and the graph's just going to grow and grow and grow. So we're actually going to say that our domain here is all real, meaning there's no restrictions on the domain. And if you play around with it on the calculator, you can actually see that you could plug in any number here and there won't be any issue. Now, however, when we look at the range, we will see that the y values can be positive, they can be 0, can be negative, but they seem to stop here at this line, that there's literally no way to get this graph to cross that asymptote. So we're actually going to say then that our range starts at negative 3 and goes to infinity. So we know that our function values have to be y greater than, negative 2. I don't know why I said negative. Nope, negative 3. I wrote it wrong right here. Have to be greater than negative 3. Now, of course, the same number corresponds to our asymptote. So our asymptote is y equals negative 3. Okay? You're going to follow the same process for all of the functions. So please get me the domain, range, and asymptote, and then go ahead and answer the 2 questions at the bottom. Feel free to ask Mr. R if you get stuck, or email me.